Today we're going to learn about the tangent and cotangent curve or graph. And I'll start off with tangent. This is the tangent equation. Looks similar to sine and cosine. But you may see that tangent is a little easier. D is still a vertical shift, up or down. But with tangent, we don't have an amplitude. But A still helps us to graph it. So what I've included, it says each period consists of 5 tick marks, including 2 vertical asymptotes. Because if you notice around the unit circle, at pi over 2 and 3 pi over 2, tangent is undefined. So when we find our 2 vertical asymptotes, we do that by using this inequality. Because negative pi over 2 would be going clockwise. Positive pi over 2 would be going counterclockwise. But you're going to use this inequality every time. So you'll take whatever is in the position of bx minus c and place it between your 2 undefined x values, and you're going to solve for x. By doing that, that's going to tell you where you're going to put your first pair of vertical asymptotes, because that would be 1 period. Now, to get your tick marks, you have to find what your period is. Find the distance between your first pair of asymptotes, and then you'll take your period and you'll divide it by 4 still. But the only difference is your first and your 5th tick mark will have a vertical asymptote. And then it says your tangent curve uses 3 points between the asymptotes, negative A, the x-intercept, and then positive A. So when you graph it, 1, 2, 3, 4, you'll be at negative A, whatever A is, your x-intercept, positive A. So your graph is going to look like this. And then if they wanted you to do another period, you'll do the same thing. Negative A, 0, positive A. And that's the graph for tangent. So let's try to do one so you can see how it works. Okay, this is how your equation looks for the first example. And they want us to graph 2 periods of y equals 2 tangent of x over 4. You can still go through and identify A, B, C, and D, just so you'll know. Let's try this again. So A is 2. Now there is actually, so I'll rewrite it like this, a 1 in front of that x, so it's like 1/4 x. So B is actually 1/4, C is 0, and then D is 0. So what you have to do first is take the bx minus c, and you're going to find your vertical asymptotes by using that inequality. you're going to put 1/4 x in the middle, and you're going to solve for x. The way that you solve for x or get x in the middle is by multiplying everything by the reciprocal, which is 4. You have to do both sides. So that's going to leave me with just x in the middle, which we want. And on the left, that would be negative 2 pi. And on the right, that would be positive 2 pi. Okay? Your period is the distance between your first asymptote and your second asymptote. So if you went from, and you do that, you can actually subtract it. You can do 2 pi minus a negative 2 pi, which will make it 4 pi. So your period is actually 4 pi units long. So you define your period by finding, and that's what period is. The period is how long your cycle is, or the distance of that cycle. So our period is 4 pi. So to find your tick marks, I'm going to call it TM. You take your period and you divide it by 4, which is pi. Okay? So when I draw my graph, I'm starting at negative 2 pi, and I'm just going to keep adding 1 pi. So that'll be negative 1 pi, then 0, and positive 1 pi, and then 2 pi, which you notice represents your first period. So I have an asymptote on the first one, and an asymptote on the fifth one. And then I do the same thing again. I keep going, adding pi to get a second period. 3 pi, 4 pi, 5 pi, 6 pi. And then my first tick mark already had an asymptote, but I have to put it on the fifth one. So when you're done, you should have 3 tick marks in between your pairs of vertical asymptotes. Okay, then you see A is 2, and we'll mark one at negative 2. So when you get ready to make your tangent curve, remember it goes negative A, 0, and positive A. And you just connect those 3 points. And then you do the same thing again. Negative A, 0, positive A. That's 2 periods. Now, if A is negative, then, of course, your graph will flip-flop. So it'll go A, 0, negative A. Okay? We can try another one. Okay, here's our second example. Like I said before, if you want, you can identify A, which is negative 1, B, which is 1, C is pi over 4, and D we don't have. So when we work this one out, remember the first thing you do is take the bx minus c and use the inequality, negative pi over 2 and pi over 2, because that's where tangent is undefined. So what you're trying to do is find those 2x values that will make tangent undefined. And you place the bx minus c in the middle, and you're going to solve for x. This time when you solve for x, you have to do the opposite, which is add pi over 4 to both sides. Which means that's going to cancel. So x will be in the middle by itself. Now, remember, to add fractions, you have to get a common denominator. So to make this a 4, I have to multiply the top and bottom by 2. And the same thing over here. So I'm going to get 2 pi over 4 plus 1 pi over 4 gives me 3 pi over 4. And over here I have negative 2 pi over 4 plus 1 pi over 4 gives me negative 1 pi over 4. Okay? Then you have to determine what your period is. You find that by getting the distance. So I'm going to take 3 pi over 4 minus a negative 1 pi over 4. So that becomes positive. So that's 4 pi over 4, which equals pi. Okay, so my first tick mark is at negative pi over 4. And remember, you take your period, which is pi, and you divide it by 4. That's what we're adding each time. So we're at negative pi over 4, because that's what our asymptote says. And we're going to keep adding 1 pi over 4. So if you're at negative pi over 4 and you add a pi over 4, that'll put you at 0. Then you add another pi over 4. And add another pi over 4. And add another pi over 4. 1, 2, 3, 4, 5. So there are your 5 tick marks. Remember, your first tick mark and your 5th one have asymptotes. And then I'm going to keep adding pi over 4 so I can get another set of, or another period. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which I have to reduce, and then 7 pi over 4. That's my next 5th tick mark, so this one needs an asymptote. Alright, A is negative 1. Now, because A is negative, that means that we have to reverse or flip our 3 points in the middle. So, since my next tick mark was at 0, I'm going to start at positive A, 0, negative A. And you do it again for the second period. Positive A, 0, negative A. Okay? So this is a negative tangent graph. And what's interesting is negative tangent is actually cotangent. So this graph is the same, or how it's going to look when we graph the cotangent graph. Okay, let's look at the cotangent graph. I gave you the equation. You notice all the equations look the same. And then I said each period consists of 5 tick marks again, including 2 vertical asymptotes, because there are 2 places on our unit circle where cotangent was undefined. And that was between 0, I'm going to use a different color, So 0 and pi were the two places where cotangent is undefined. So what happens is when you have a phase shift, which is the bx minus c, then that also shifts where your vertical asymptotes are. So you're going to do the same thing we did with tangent and start off with this inequality, and then you'll solve for x. And you still find your tick marks you have to first find your period, because you have to find the distance between your first and your second pair of asymptotes, and then do your period divided by 4 again. Okay? Then your cotangent curve includes 3 points between your asymptotes. I'm just going to make this up. So let's say this was your period, or your asymptotes. Then when you graph, this time you're going to start at positive A, your 0, and then negative A. So the graph of cotangent, if you notice, is the negative graph for tangent. And the negative graph for cotangent, of course, is going to be the graph for tangent. So if A is negative, it's going to go this way. If A is negative. Okay, so let's try a cotangent graph. Okay, here's our graph. I'm going to identify A, B, C, and D. So A is 2, B is pi over 4, C is 0, and D is 0. Alright, so the first thing you do is find your asymptotes. Remember, we have to look at where cotangent is undefined, which is at 0 and pi. And then we take our bx, so remember b was pi over 4, x minus c, but c is 0, so you don't have to write that. So it's always bx minus c. bx. And then you're going to solve for x and get x in the middle by itself. So the way that you do that is you multiply by the reciprocal, which is 4 over pi. You have to do it to both sides. And then 4 over pi. Well, that leaves us with x in the middle. On the left side, we still have 0. On the right side, the pi's cancel, and we have 4. So your period would be the difference between 4 minus 0, which equals 4. And then to get your asymptotes, well, of course, my first one's at 0. To get your tick marks, TM, take your period divided by 4, which is 1. So 0, 1, 2, 3, 4. And then 5, 6, 7, 8. So when you draw your asymptotes, you should have 3 tick marks in between them. Okay, remember this is cotangent, so we start at second term. A, 0, negative A. A, 0, negative A. So that's 2 periods of cotangent. All right, let's try one more. Okay, let's look at this one. It's probably as hard as you'll get. So, A equals -2. B is 1. C is negative pi over 6. And D is -1. So I made sure this one has everything. So the first thing you want to do is find your vertical asymptotes. Think about where cotangent is undefined, and that's in between 0 and pi. So you're going to take bx minus c, minus a negative makes it plus. And you're going to solve for x. So I'm going to subtract pi over 6 from both sides. So on the left, I get negative pi over 6. But on the right, I have to change this to 6. 6 pi over 6 minus 1 pi over 6 gives me 5 pi over 6. All right, to find your period, you're going to take your largest, which is 5 pi over 6, subtract your smallest, and you're going to get 6 pi over 6, which equals 1 pi. Let's find our tick marks first. Take your period, TM, and you divide it by 4. So that's what we're adding each time, but we're starting at negative pi over 6. Now, if you notice, the denominators are not the same, so we can't just add it like it is. So the common denominator for 6 and 4 is 12. So I have to multiply this by 3 and this by 3. And I have to multiply this by 2 and this by 2 and this by 2 and this by 2. So I have negative 2 pi over 12 and 10 pi over 12. And this is 3 pi over 12. That's what we're adding each time. So if we're at negative pi over 6, which is negative 2 pi over 12, and we add 3 pi over 12, that'll put us at positive 1 pi over 12. And if you add 3, 1 plus 3 is 4 pi over 12, which is pi over 3. but I'll write it right here. Then add another 3. That's 7 pi over 12. Then add another 3. That's 10 pi over 12, which is 5 pi over 6. Then add another 3. That's 13 pi over 12. And then add another 3. That's 16 pi over 12, which is 3 pi over. So 16 pi over 12. I'll put it underneath here. 16 pi over 12 reduces to 4 pi over 3. And then you got to make sure now you have 1, 2. We can't count 0. 1, 2, 3, 4, 5, 6, 7. We need 1 more. Actually, 2 more. 19 pi over 12. Because see, we got an asymptote here. An asymptote here. We need 1 more. So 19 plus 3 is 22 pi over 12, which reduces to 11 pi over 6. So that's my last asymptote. Okay? And we got 2 and negative 2. Okay, be careful when you do this because I know you have a tendency of making 0 one of your tick marks, but in this case it's not. So when you graph it, your next tick mark was pi over 12. This is a negative cotangent. So then that means it's going to look like tangent. So we're going to go negative a, 0, positive a. Then you do it again. Negative a, 0, positive a. And then that's your negative cotangent. So negative cotangent looks like tangent. Negative tangent looks like cotangent. And we're done.